Inverses, right? Every time they go near each other, they cancel each other out, right? They undo each other. So, so let's continue. So here's another properties here, the products and quotient properties and the power. All right, change of base. Change of base. If I have log base b of n, it's the same thing as writing it as log n divided by log b. In case this is base 10, write it. Or if you want to do natural log, you do ln n divided by ln b. Please remember, b is base, so it's going to be at the bottom. So let's do this. If I have log base 2 of x, I can write it as log x divided by log 2. It's a base 10, so I don't write it. Or somebody else can do like this. ln of x divided by ln of 2. It's the same thing. So far, so good? Let me ask you a question. What's log 1000 equal? You should be able to tell me right away. Log of 1000. Anyone? 3, right? Thank you. Bonus check mark for you. 3, because it's log base 10 of 10 cubed, right? Remember the base, the log, and the exponential, they cancel, so it's equal 3. Now I'm gonna use the change of base, and your answer should be 3 as well. So change of base say is equal to log 1000 divided by log what? Log what? 10, right? Log 10. Log 10. Running red, log 10. What's log 10 equal? Log base 10 of 10. You 1, right? If you forget, just write out and then cancel it. Right? So just 1. And then log 1000 is 3. So 3 over 1 is 3. It's the same thing, right? It's the same thing. Now, why do I need this? Because most of your calculator have any log, have any base you want, right? You want base 5, base 9, base pi. Now, my calculator is the old one. It only have log base 10 and log base e. So it's kind of helpful for me to do that. If I want to get numerical approximation, right? So some problem is not nice and neat like this. It's not a decimal. So I have to use the change of base to get the numerical approximation. You guys don't have to if you have one of the fancy one. So back in the day when the TI-84 Plus not coming out yet, this rule really helpful. But now, not really. Maybe for me, but not for you. All right, here is a summary of log. I want you to spend half a minute just to read that. Just to read that over. Most of them you already know. So you know this one, right? You know this one. You know the inverse properties. Let me do like this. So these two are the basic property. These two are inverse properties. ln e equal 1, which is true, right? Because ln e is the same thing as log base e of e, which is 1, right? What's ln? Let me ask you a question. What's ln of e to the x equal? What's ln of e to the x equal? X, right? I just wrote that, right? ln and e, the inverse. Remember, log base e and e inverse, they cancel. Every time they go near, they cancel. So x. So x. What about this? ln of 1. What's ln 1 equal? If you don't know, change it back to base e. Log base e of 1. Yeah. The little arrow thing. Well, it had to be 0. It has to be 0, right? E to 0 is 1. So ln 1 is 0. You know these three, right? Product, quotient, and power rule. This one, a change of base, we just did it a minute ago. The last one is kind of newish. It's not something you haven't seen. You kind of seen it before. Do you remember this? Don't write this down. If I have 2x equal 2q, then what can you conclude? Yeah, x equal 3, right? If I have logs of x equal logs, say log base 2 of x equal log base 2 of 10, then yes, it's x equal 10. I can do the same thing with log, right? So in general, if you have log base b of m equal log base b of n, then it's m equal n. Maybe I should have put if and only if. I should have done like that, but it's okay. Just remember that. Rule number 10. All right, let's solve. Now that you know a bunch of rules, let's solve. Log base 4 of 24 equal 2 times log base 4 of x. It's a good habit to put the parentheses for the input. It's a good habit. Now, can I drop the 2 log and let 24 equal 2x? No, why? Yes, no, can't. Not yet, not yet. We will eventually, but not yet. Why? What should I do first? Remember the rule. The quotient for the log, sorry, not quotient, the coefficient for the log, what does it have to be? It has to be 1, right? Nothing attached in front of it. So I have the 2 attached to it. I need to get rid of it. No, if I divide them, this one got 1 half attached to it. I need to bring it somewhere that is no longer to be in front of log. What rule allows you to do that? The parachute rule, right? Parachute. Remember, you bring the parachute down, now you can bring it back up. So I'm going to bring the 2 back up, the power rule, right, back up to the x. So that log, rewrite the left-hand side, logs of 24 equal logs base 4 of x squared now. Now I can drop those 2 guys. So that 24 equal x squared. Square both sides, plus and minus. X equal plus and minus root 24. I don't know. Okay, someone simplify root 24 for me. No. Still exact answer. Yeah, still exact answer. I just don't like root 20. You still can simplify it. It's 4 times 6, which is 2 root 6, right? Yeah. Yeah. Yeah.
I put the exact answer on test or quiz.
Depend. Sometimes I ask you to use numerical approximation. I'll let you know. But you always have the exact answer. Otherwise, how are you gonna get the numerical, right? Approximation. You always have the exact answer. Now the things that I have positive, negative. What should I choose? Or should I choose both? By the way, so for log equation, you must check. You must check. Is that okay if I pick positive 2/6? Let's do the negative first. What happened if you put the negative in?
Get it wrong.
Yeah, it's undefined, right? If you put in your calculator, if you plug in the negative 2/6 into the original right here, let's say out of domain or error or whatnot, my calculator will give you a imaginary number though. But the positive is okay. So let me check. Let me check. We can check. Someone remind me the left hand side. I forgot. So logs base 4 of 24.
Yeah.
Thank you. Math. Remember, go to math. The upper arrow log base. Base 4 of 24. All right, it's 2.29 something. I want to check if the answer is correct. So I'm gonna do 2, and then square root of 6, and then I'm gonna store it. STO. Have I showed this? I think I did. I don't know. STO allows you to store some number into a variable. I'm going to choose X. So right here, X. Store in X. Press Enter. So next time you press X, is that number, right? It's remember is storing is the right value. What's the right hand side? 2 times something 2. Yeah, logs base 4. So math again. So logs base 4 of X. Very good. It's the same. It's the same, right? So that one and that one, the same answer. So yes, that's the right answer. Now, let's see what happened to the negative one. So negative 2, 6. I know I store as X. Let's just see what happened. 2 math logs base 4 of X. Well, your calculator will say out of the domain, but what happened to my calculator? It gives you what? It gives you imaginary. So you know that it's not a real solution. We want real solution only. So only positive for the input. Now sometimes negative number works. Depends. For example, if I say don't write this down. Okay? Say for example, I have don't write this down. Logs of X minus 2. No. 2 minus X. So 2 minus X. All right. Now, if I saw and then X equal negative 8. Just say that. Okay. X equal negative 8. It works. In this case, it works, even though it's a negative solution. But remember, that's why you check. What the check part for? When you plug it in, what does it become? Positive, right? 2 plus 2 minus 8, so 2 plus 8 is 10. So it doesn't matter what the solution is. It matters when you plug it in, right? As long as its input is positive, you're okay. So sometimes negative answer works. All right, so why don't you guys do number 2? I'll walk around, see how you do. Do that one. Yeah, usually I don't put time to see but it's a good habit to do so. Yeah, they just cancel more. Well, I can walk around.
This Friday.
No, Friday is Wednesday. Right, what do you guys have? What you guys have? X equal. Right, if you have X equal 3, give yourself on the check mark. So for X minus 2 equal 10. For X equal 12, X equal 3, and you're gonna check. Right. 4 times 3 is 12. 12 minus 2 is 10. So log base 5 of 10 equal log base 5 of 10. Now on the exam, you don't have to show me the check part. As long as you box it and then you put some sort of like check part, I know that you check. This one. Can I cancel log? They have the same base. Can I cancel it? Huh? Yeah, they both base. But can I cancel it like I did before? Yeah. Well, remember the rule. The rule is what? The rule is what? Logs baby of n equal logs baby of n. So single log for each side, right? You can, right? It doesn't look funny. So what I can do first is I can combine them. Combine them. Sum becomes product, right? So if I want to be one log, so product means what? You multiply the input. So here is one input, and here's another input. So x times x plus 3, and if you want to put a bracket around it, it's fine too. Logs of x squared plus 3x. I just distribute x equal 1. Remember the arrow thing? So now 10 to the first equal x squared plus 3x. How do I solve a quadratic equation? Move everything to, yeah, to the right or to one side. On the exam, I'll let you, it has to be factorable. I'll let you be able to factor it. Factor it for me. X minus 2, right?
Yeah.
Yeah. Sure, yeah, sure. I'm not stingy about the check mark. I'm stingy about giving you what give you on the exam though. But, you know. So x equal -5 or x equal 2. All right, now it's time to check. Is a 2 okay? Look like first line, yeah, at least it doesn't have a negative input, right? So it's okay. It's definitely not -5, right? When I've been checking the answer, I know -5 is not gonna work because when you plug into the first log of log -5, it's bad, right? So you cross that out. So on the exam, you do that, I know that you check. Now let's check x equal 2. I'm gonna plug into the equation. So log 2 plus log 2 plus 3, which is 5. Check. So log 2 plus log, it's log 5, 1. So yes, it checked, right? It checked. It's equal to the right-hand side, so it checked. So that's how I want you to show your work, right? You don't have to show me how you check. Just make them do something that I know that you check. Why don't you try 4? Just a little bit. Can I cancel log? Oh, very tempted. I'm like, Mimi, I got log weight 10 8 both sides. Can I cancel log? No. Remember what I say. You're only allowed to cancel if you have what? A single log on the left and a single log on the right. Right? And they have the same base and no coefficient in front of them. Let me ask you again. Can I cancel them? No, not yet, right? Not yet. On the left-hand side, what should I do first? Yeah, how do I do this? No, it's not a product, it's subtraction. So subtract goes with division, right? So which one on top, which one on the bottom? Mm-hmm. Yeah, why? It's right, but why? It's a minus, right? Whichever log, if it carry the minus, then it's gonna be in the denominator. You want, you can put a little parenthesis. You want on the right hand side, I need to get rid of the negative in front of log. It's actually -1 times log. What rule can I allow me to do that? No, then I have a negative here. Remember, I tried to clean them up. Yeah, you put it in the top, right? You remember the parachute rule. So, so that's become logs of x to the -1. Now you can cancel. So I have x plus 4 over x plus 5. Sorry, 5x plus 12. X to the negative first is the same thing as the other way around. 1 over x. You can crisscross multiply because you have one fraction on the left and then one fraction on the right. Well, let's do LCD. Let's do LCD. What's my LCD here? Yeah. Maybe I'll leave it as factor. So x times 5x plus 12. And now you distribute. So on the left-hand side, the 5x plus 12 cancel. Which is x times x plus 4 equal. The right-hand side, the x cancel, which is 5x plus 12. Square plus 4x. Subtract 5x, subtract 12 equals 0. X squared minus x minus 12. Can someone factor this for me? Factor it. Thank you. So that imply x equal 4 or x equal -3. Well, I know -3 not going to work, right? Just on the right. Negative input. And again, sometimes it doesn't mean negative solution. I mean, you get rid of it. Sometimes it works. Sometimes it works. It's not in this case. 4 works. I don't know. Let's check it out. It's a good thing to check because sometimes you get the answer. It's positive. Yay, it looks good. What if something wrong over here? That you make some mistake here. That might be not the correct answer. So let's check. X equals 4. So I'm going to store x at 4. That's TOX. On the right-hand side, that's negative log x, right? So negative. So you use the opposite key. Don't use it. It won't work. So negative log x. That's my answer. All right, let's see the left-hand side, the same thing. Remind me the left-hand side. Yeah, the left-hand side. Log x plus 4. Yeah, original. Okay. And then? Yep, same answer. So you know the x equal 4 is correct. All right, last slide. Let me remind you something, which probably gonna be on the exam. I'm sorry, yeah, on the exam and the quiz. If I have 2x equal 4, then what will you do? Very good, because what? Well, you do what? 2 to the x equal 2 squared, and then you cancel, right? You cancel the 2. Right? I shouldn't say cancel, but it's just quick. So x equal 2. Now, what if I have something like this? I cannot change the 3 into something base 2. Right? Then I have to find a different way to solve for this. Okay? All right, so let's solve 3 to the x equal to 89. Again, I cannot change 89 into base 3. Remember, 81, 3 to the 4. It's 89 is a prime number. What I can do is, maybe I'll show you 2 methods, and you tell me which one you like. Not everybody have a fancy calculator, so I'm going to show you both methods. Yeah, the same answer, it's just different way of doing it. Now, I'm going to take log base 10s both sides. So let me rewrite this. Leave a little space. Remember how we're allowed to take what's like square both sides, things like that, right? We do the same thing. We take log both sides, log base 10. You're allowed to do that. Do you agree with me on the right-hand side? It's just a number. If you plug in your calculator, it'll give you some kind of decimal. Right? It's just a number. Just what we're looking on. On the left-hand side, it's not, right? Because it's carrying the variable. What can I do with this variable? Yeah, put it in the front, right? Put it in front. So need to bring it down to earth. So that'll be x times logs of 3, and then equal logs of 89. Remember, V2 is just a number. It looks funny, but it is a number, just constant. In order to solve for x, what should I do? Divide both side by. Yeah, remember, it's just a number. Just like you divide both side by 2, divide both side by 5. Let's cancel. So x equal logs of 89 divided by 3. I'm probably gonna ask you to round it up to 4 decimal places. One point. Oh, I'm sorry. Sorry. Oh, no. I wrote it wrong. Logs of 89 divided by logs of 3. Sorry. All right, log, clear that. Logs of 89, then divided by logs of 3. 4.0857 this will be your exact answer. This will be numerical approximation. And if for these kind of problem, logs base 10s always work. Any problem. Now let me show you the quicker way. I think you like this better too. Rewrite the problem. 3 to the x equal 89. Instead of taking logs base 10, I need to bring x down. Remember, your goal is to bring x down. You can solve for x. What cancel 3? What's the inverse of 3 to the x? What cancel 3? Logs base what? Base 3, right? Logs base 3 cancel the 3. So if you add log base 3 to the left, you do the same thing to the right. Done. X equal logs base 3 of 89. And it's the same answer. You just write different. Do you remember the change of base? Change of base. Log base b of n equal what? Log n divided by log b. Same thing. Yeah, you can do this. Math. So logs base 3 of 89. It's the same thing. Which one you like better? Yeah, me too. The left one is for people who don't have, your calculator don't have a different base. If you have just base 10 or base E, then I recommend this one. If I ask you numerical approximation, you cannot do that. Or maybe you can do this, but then if you know your change of base well, you can change it to here. Why don't you guys do that one? Number 2. What's your answer? The exact answer. What is it? You get that? Give yourself a check mark. So take logs base 5 both sides. One, you can do a little parenthesis. Oh, by the way, when you write these, please, if you write the base, make it a little lower, okay? So that I know it's a base. So that x equal logs base 5 of 110. What is the numerical approximation? What after 6? So 7 then. Oh, okay. 5, 6. So 6. Thank you. Number 3. It's the same thing. It's just base E. So what should I take? Kind of log both sides. What kind of log? Yeah, natural log, right? So ln both sides. black. ln both sides. Let me write it neatly. Sorry, this does not look good. Like that, right? And you know the E and ln E, they cancel, like the inverse, they cancel. So it's just 2x equal ln of 24. Now what I see people do is they do this. They do this, which is correct. They cancel the left-hand side, which is correct. And then they go ahead and remove the ln as well, and then just 2x equals 24. It's a common mistake. I know you don't mean it. It's just you can't keep canceling things. Just keep out that rule. So don't do that, okay? You only cancel the left. You leave the right-hand side alone. Divide both sides by 2. So x equal, is x equal ln of 12 or ln of 24 over 2? Yeah, those two different things, right? Remember the 2 is over the whole thing, not just the 24. That's another mistake you might make. Notice that I don't check my answer. Oh, you should. You should. I'll check this one. Just I'm not going to ask you to check because these problems they don't have extra problem, so I don't ask you to check. The log has extra solution. So let's check. ln of 24, and then go out of the parenthesis, divided by 2. I'm going to store in x. And I got e, so e to the some power, e second ln, e to the something, 2x. It's 24, so it's checked, right? So that means you got the right answer. Now, if somebody say ln 12 and check this and look out 24, you know you got it wrong. All right, last one. We did with 3.2. Why don't you try that one? I'll give you a second. You try that one. Anyone else? You had it right before, but you did something. You think causing right is fun? Yeah. No, leave it alone. Remember what I said. What inside input, they belong to ln. They don't share or they don't add anything. That's why I say don't divide it by 2 on that one. All right, subtract 2. So what most of you did, right? So that cancel. E to the x plus 1 equal 14. Now I can take ln both sides. What did you do? Oh, okay. All right, so now E, ln and E, remember the inverse or cancel. So x plus 1 equal ln of 14. Subtract 1 both sides. Tempted, but do not take 14 minus 1. Somebody give me a numerical approximation. Thank you. Very good. See, you got, bless you. You can include a 0 because I want 4, right? I want 4. It's kind of like this. If I say don't write this down. Say x plus 1 equals the square root of 2. When you subtract 1 both sides, what's equal? Square root of 2 minus 1. Right? You don't take square root of 2 minus 1 and become square root of 1. Right? You don't do that. Same thing with ln and log here. What inside the square root stay inside the square root. They don't share or add anything to it. Yay, we've done 3.2. On your quiz, I want you to take a look at objective 9, solving log equation, objective 9. Yeah, objective 9. There's more though. There's just one question. 2 questions on your quiz. But this one worth 4 points. Let me fix my notes a little bit. Oh, it's dark. It's dead. I can't fix it. Let me show you something before I actually started.